Good morning. This subject here is really relevant to discussion of virtualization, but it's put in a simple terms. So if you're not familiar with virtualization, you should be able to grasp the concept of vMotion of virtual machines. And Justin is my friend from Ball State, friend and colleague from Ball State University. We did this presentation at the conference, so I thought you might be interested to see those. Specifically my students from my class, because we talked about vMotion and data centers for that matter. vMotion is proprietary technology by VMware, and what it does, if you have two separate physical hosts, you can move virtual machine from one host to another one without shutting it down. It gives a lot of flexibility because if users are currently logged into the host that runs the virtual machine, they don't even notice anything. They just migrate to a different physical host. Of course, it sounds, simple, but there's a lot of things that happen in the background. And let's see what they are. The next slide will show how vMotion works. But zero downtime with virtual machines is really nice because if you think about this, you have a physical server that you want to upgrade. You can move virtual machines from that server and put them on a different server, then upgrade this server and bring the machines back. Besides doing that, there's also something called distributed power management. It's the load balancing on the clusters of servers, and the load balancing technology looks at the load of the servers, and if there's a situation when one server is not doing much and this one has some space left in terms of resources and CPU, vMotion will automatically move the machines and put this host in the standby. So that saves on power and cooling, and if you have large-scale deployments, data centers with thousands of servers, imagine that, let's say 1,000 servers, 800 of them will go into standby mode at night, and 200 will bear the load. If in the morning, well, I shouldn't say if, they should be at work. When people show up for work and it starts to increase the load on the servers, let's say on those 200 servers that run the data center, it wakes the other ones up, moves the machines to them, and that's how it load balances. Saves a lot of money on power, and then just not the power alone, the cooling is a really big aspect, because if you shut down many servers in the data center, then the cooling cost goes down immediately. That's two main concerns right now in data centers. There's automatic and manual migrations of the VMs. You can schedule them to be completely manual or completely automatic. So it's up to the administrators. The way it works, I want to show you, before I do the animation, I want to show you a couple of things. You have to have a dedicated gigabit network for vMotion migration. So just the migration itself must have that. But then if you look at the production network here, this is where that user is logged in to that VM. So VM is running on ASX1, and the VM is using the production network. So it could be connected anywhere from that point. What we do is we create a bitmap of the memory of the VM from this host. Since virtual machines now are all software-based, everything about the virtual machine is a file. So that state of the memory could be saved as a file, and a bitmap could be moved and applied somewhere else. We're not dealing with hardware anymore. And once that bitmap is applied, an identical VM is created here on a secondary, on the destination physical host. And as soon as it says I've created the VM, it deletes this machine and reconnects the user. So the machine state, anything, the data in the machine, nothing is lost. The only thing that might happen is there'll be a delay, maybe a second on the screen. And what that delay is, it's almost like you went and you unplugged the VGA cable and plugged it back in. But the machine, yeah.
How can it be so fast? Doesn't it have to move many gigabytes of stuff at once?
This is a great question because, and this is what the presentation is about too, that shared storage is essential. Large files, virtual disk files, and configuration files, they stay on the same storage. All we do, we move the bitmap of the memory. We only move the memory from one host to another one. But vMotion requirement, you have to have shared storage.
How fast is the network going through the shared storage?
That depends on your network. It could be fiber channel, could be IP, SAN, could be NFS. So
That'd be something really fast.
I can tell you that this connection to the storage here, that is not the most important thing. What's important is the gigabit network here, because these files, what happens is at this state, when the memory is created and we have an OK that this VM is created, this host will release the locks on the files. And nothing happens to these files. It just says, I'm no longer owned by ESX1. And as soon as that happens, then this server will lock the files on the shared storage. There is another technology that's called storage vMotion. And with storage vMotion, you can move everything from your storage to a different storage. vMotion is just a migration of a VM, but you can take the folder of the VM and move it to a different data store. And it's not dependent on data store either. Could be from local to fiber channel and so on. And that is a very good question because it leads into several other things. If you let me go back here. If you think about this, if you don't have shared storage, vMotion doesn't work. So this is the major limitation. You have to have shared storage. So what happens if you have a server in Frisco and then a server in Dallas and you don't have shared storage between them? It's been a major challenge for vMotion until I think May 2010 because there's a new technology that came out. And I'm going to tell you about that just in a couple later slides here. What's really important, same CPU vendor needs to be on both hosts. You cannot do a live migration of AMD host to Intel host because a set of instructions, if a VM is using the set of instructions on the AMD host, it can't just wake up on a completely different set of instructions. Gigabit network, local resources can't be connected because if you're trying to move VM that is using the local host, then obviously the second host is not the same host, the destination host. Storage connections, this is where we can't vMotion between the source host and destination host if we have two different storage technologies. It's not even the difference in technologies, it's just not shared. And this is the correct way to vMotion. They must have the same storage. And they have to be in the same data centers. Data center is where you create the clusters of resources. This 2210 is the data center. And by the way, for all the people in my class, this is what you see when you do a vCenter. You have a vCenter here, and then you have clusters of hosts where you create multiple hosts. It's relevant to our discussion about cloud computing today. So if this was in Dallas and there's another data center in Frisco, vMotion doesn't work until, and we've discussed these, until you have this. Of course, it's always in information technology say, this is it, we can't do it. And like next week they say, we've created something to solve the problem, So, and the answer would be EMC's vPlex. What happens here, vPlex is a virtualized layer of two different storage destinations, I guess, two different locations of storage. Once you have to have a connection here between those devices, but then vPlex is the layer that presents both of these as one storage to both hosts. So that solves the problem of shared data store. And as soon as that happens, you can vMotion between geographical locations and data centers because now you have no limitation of the shared storage. And this is the official slide from EMC. And Grace, you said I was in trouble. I have a reference there. This is a synchronous distance. What that means, this is replicated 100% synced at all times. And synchronous distance means that it's limited to 20, officially 60 miles, but the best way would be 20 miles between those data stores. But synchronous replication has a lot of requirements for latency and bandwidth and so on. So it needs to be pretty advanced in terms of the connection. But again, this is brand new because the distributed virtual volume is presented to hosts and separate data centers as from one storage. So that's really important. And now, all these nice things available. We can do backups and disaster recovery because hosts view that storage that's virtualized and spread out, and you can take that storage and back it up to different destinations and replicate that storage and so on. And this is an animated slide here where you have, I guess it's semi-animated because I have to click, right? All right, so if we have Frisco storage and Dallas storage, what we can do, we can create the vPlex cloud, and that cloud, that virtualized entity, will be presented to as a virtual SAN to whatever host is in different locations. So once we virtualize that, in the background, we can replicate each one of these entities separate. And replica is a bit-for-bit identical copy of your storage. So besides being able to back the virtual SAN and replicate that, we can make sure and have a second backup of each destination, source and destination, at two different locations. Just to remind you, this is a synchronous distance. So if you're familiar with synchronous or asynchronous really doesn't have a distance limitation because it's done over time. They update if something moves from one place and goes to another one, it will update as soon as it's ready, as soon as it's written the data. Synchronous doesn't work that way. Synchronous doesn't proceed until the destination host confirms that it's been written. So it's always updated on both ends. So this is really exciting technology for virtualization because essentially what we come into is the Skynet from Terminator movie. Remember that? And it's funny, but at the same time, I think that's a perfect representation of what happens in the cloud computing because since we virtualize all these entities, we have this storage that looks like a local disk on the machine, but it could be bits and pieces from different ends of the world, and you can't really kill that storage anymore. And that's the first thing that comes to mind. And I actually showed them, my students, I showed them the video of Skynet in one of my classes. In Kim's class, the EMC storage class. So
if a synchronization is in progress and the user is asking for that data that's being synchronized, you'll get some sort of a flag that says, hang on a minute.
Well, if you satisfy the requirements, it's not going to be anything, there will be no delays because the latency is like 5 milliseconds requirement, so you won't, the maximum latency is required is 5 milliseconds, which is, in human terms, that means nothing. So usually with EMC, I was going to say this is fiber channel implementation with vPlex, so it's usually fiber.
Can you make fiber that far? I mean, fiber
20 miles, yeah. 20 miles, yeah.
miles.
Yeah. 60 miles, you can do it.
So how many gigabits?
I couldn't tell you. I have to look up the requirements, but they have. It's some of these technology you have to really specifically follow all the requirements. Otherwise, it won't be synchronous. And you know what happens if it's not synchronous? That means you can lose some data. But I suspect that IPsend virtualization between different locations will take place as well pretty soon. Something like vPlex. If you're interested in IP version of that, you should look into Left-Hand Networks SAN. They do similar things, and it's pretty interesting how it's done. All right, so on that note, if you have questions, I don't know if I took my 3 minutes back, I guess.
So this is it's a data center to data center product. That's what it's directed.
It's mostly think in terms of different geographic locations, because we want to have backup and disaster recovery in different entities, and now we can move VMs between Dallas and Frisco, for example.
Let me ask you this question. I have a friend who owns a chain of golf supply stores.
Mm-hmm.
He's got one in Hartford, Connecticut, one in the Virginia area, one in Florida, and he's constantly having inventory problems. Is this an application that a business like his would use? I mean, could it be used by a retailer, point of sale, or that kind of thing, for inventory control, for that kind of stuff, or is it for larger data center kind of applications?
Inventory control is no problem, but you'll have to be asynchronous application. It can be synchronous.
It has to be asynchronous. So it would be asynchronous over the internet.
Yes, you can do it over IP.
And how frequently can you?
It depends on the traffic, but you can lose the packets too. But the update of the inventory could be applied easier. You don't really, he doesn't really need to have synchronized storage. He can sync the VMs and apply it to database or something.
So this would be an interesting, in the point of sale area, cash register kind of application.
Well, there's a lot of things that will come out from virtualization of storage and virtualization of servers, because the cloud computing is on the rise, and basically now you can tap into resources that are located somewhere we don't know where. It all comes down to CPU cycles and gigabytes of RAM.
So even in the asynchronous example, we're only talking updates. I mean, he's talking inventory, so if it's twice a day, I mean, you're talking about minutes to do the complete transfer or whatever?
The way usually replication is done is only updates via logs, and the logs are easy to push through any system. So you don't really take the database and move it to a different place. You just compare them to, and you say this 0 and 1 is different than this, so apply 0 and 1 here.
He batches. Everything goes at like 2 in the morning now. But if somebody walks in and says, "I want to buy this, $700 golf club," he doesn't have it in that store. He wants to see if he has it in another store, and they'll have it FedExed for the person the next day. So, right now he's picking up the phone, saying, "Hey, you got this thing in stock."
What you can do is, let me show you. He doesn't even need the replication between storage. What he needs is you can put 2 different data centers under the same VC, and the requirement for that is you can.
So you can see either.
Yeah, you can have 100 megabit network between those 2 data centers, because you're not really like pushing a lot of data, and he can have his VMs in, let's say, Florida and one in Indiana here, and right click on that VM and open the inventory from that VM and just see it from anywhere. Yeah. And with the next feature of virtualization with VMware, the virtual centers now can be linked as well. So it just grows exponentially. Yes.
How current or how old is this technology?
This is came out 2010.
Okay, do you know any major corporations, internet corporations that are using
Are you talking about the vPlex or are you talking about the virtualization? vPlex is, I think, May 2010 it came out. And they're already advertising it heavily, so I think it's really a nice positive step. I don't know how many corporations are using it, but anybody who wants vMotion between two geographical locations will jump on it right away.
Who was that company you mentioned? Was that Macy's, did you say?
Huh?
What was the name of that company you mentioned? That
EMC. EMC, it's those books that are going to be raffled today, that's from EMC. And EMC actually owns VMware. They have majority of stock.
In your example, you were synchronizing two servers. Can you synchronize more than two?
You're talking about two storage arrays, right?
No, I'm talking about the servers.
The servers are not synchronized. If you, let me show you. Are you talking about this slide?
Yes. You have an EXO3.
You can move this VMA to any storage. I mean any server that connects to the same shared storage, and on the same vMotion network.
That was my question.
Yeah, but you don't really compare ASX1 to ASX2. They just meet the requirements. That's all. Because there's nothing happens on the servers themselves. They just accept the VM with the new bitmap and release the lock. But you have to have the production network on wherever destination host you have, because if you don't, then users will be disconnected from that VM. Thank you.